Hi friends, welcome back to another session. Now let's see what multi-level queue scheduling is. So multi-level queue scheduling divides the ready queue into multiple separate queues where each queue has a specific priority or job type and uses different scheduling algorithm. Processes here are permanently assigned to a queue based on their characteristics, like the process may be a system process, or it may be an interactive process, or it may be a job process, and so on. And each process may have a different priority, like the system or kernel process may have highest priority, and the interactive process may have moderate priority, and background or the batch processes may have least priority, and so on. And each of these processes may use different scheduling algorithms, like kernel processes may use a high priority round robin method. Then the interactive can have a round robin, and the background or the batch processes may use first come first serve, and so on. So here we have various types of processes we can look at. So the highest priority is given to the system processes that run under the kernel, and then the next priority is given to the interactive process. That means where human is interacting with the system, and that has to give immediate attention. But of course it is not that important as of kernel process, therefore it important but not that important as a kernel process, so it has given the second level priority. Then we have interactive editing processes like word processor and all that, where we keep typing and all that, and we would expect whatever we type should be visible on the screen at the earliest, therefore should be having a higher priority, but definitely not as high as interactive processes or system processes, so they take a third level. Then we have batch processes, where a batch of processes do, and there is no need for getting the work done at the earliest and all that, so there may be a delays and all that can be tolerated with such processes, and therefore they have a lower priority, and so on. So if you look at the positive part of working with multi-level queue scheduling, so we have very clear prioritization. So the critical tasks like system processes always get first attention. So flexibility, so different algorithms can be used per queue. So it may be round robin, it may be first come first serve, it may be shortest job first, etc. So different queues can have a different algorithms, not necessarily that all the jobs in the system should work with only particular scheduling algorithm, and so on. And as far as the efficiency is concerned, it keeps the system responsive to the real-time and interactive task at the earliest, and the slow processes may be delayed, but the one which needs immediate response are addressed immediately, almost at the real time, therefore it will be highly efficient. Now looking at the negative side of that, that's starvation is a major concern here for low priority processes. So low priority processes may never get the CPU time, because every time a low priority process tries to get the CPU, some high priority process may be available in the higher queue, therefore this low level processes may never get chance to run, and hence will have a starvation. And there is a problem with the rigid design, that once the process is assigned to a queue, then the process cannot be switched from one queue to another queue. So at the time of allotment, any new process comes in, then we have to decide exactly to which queue it should belong, and should be assigned to the appropriate queue. And if something goes wrong in allotting the queue, then it is not possible to change in future. So by mistake any critical process is given a lower priority, then it's going to create a major problem in future. Or by mistake, if any system, any process that's going to take too long, and if by mistake if it is allotted a higher priority, though delaying that may not cause a major problem to overall system efficiency, overall turnout and all that, but still by mistake if it is given a higher priority, then it will disturb definitely other processes that were more important, more urgent than this particular one. So even if we understand that something went wrong, it is not possible to correct it once a process is assigned to a particular queue. And because of this rigid design, it is not possible to change the process from one queue to another queue. And a lot of complex setup is required, a very careful queue design is required, and very complex classification algorithm is required to identify the importance of every process and to ensure to which queue the current process to be assigned, so to which queue this particular process should be added to, so that it's really a great challenge in making things work perfectly. So a lot of challenge we have in designing queue designs, that is identifying to which process to be added to which queue and all that. So that's some details about the multi-level queue scheduling, and that's it for now. Thank you.